Good morning, friends. We will continue our discussion on Apache Spark shuffles as we discussed in the previous video as well. So, as we discussed that there are certain operations which can trigger the shuffle event. Shuffling is actually moving all the data across all the partitions which are spread across various worker nodes. So the operations which can cause a shuffle include like repartition, coalesce, groupByKey, reduceByKey, cogroup, and join, etc. So the challenge is that, so for example, if we call reduce by key operation, or the method, it will try to like reduce based on the key that we have given, and the reduction function that we have applied on all those values of based on that key. Because our data is spread across various RDDs across various worker nodes. So what Spark does is that it will find all the values for all keys and then bring together values across partitions to compute the final result. I mean, the reduction function that we have applied. And this whole event is called shuffling because lot of data pertaining to the values associated with all those keys are shuffled across. Because we are doing a lot of shuffling across various partitions, various machines, various worker nodes. So it means that it will involve a lot of disk I/O, and data serialization and deserialization, as well as network I/O. And it can also trigger a lot of garbage collection as well, because Spark will try to optimize this process by grouping all the values across the partition. And it will try to store in the memory first, and whatever data it can fit into the memory, all the extra data is spilled over to the disk. And it also tries to maintain a cache so that, I mean, if again the same type of reduction is being applied, it can reuse those values from the cache to get better performance. So we have learned on this, and whatever the things that we should always try to avoid shuffle operations, but we cannot avoid it at all because we have to use all these like reduce by key, aggregate by keys function in Fungo. The only thing that we should avoid is which is the better way, which is the better method to perform a certain operation. So enough said that. We already discussed about all this in details in the previous video. So today I have just going to the source code where we'll be actually writing some code to see about the performance impact. So I have my IntelliJ open now. So I have created a very basic test case. Here, what I'm doing is that I'm creating a Spark config, Spark conf object, and I'm using my local stuff. I mean, which means I'm using all my 4 CPU cores here. After this, I have created this word list.txt.dl, which contains a lot of words, but still in context of big data, it shouldn't. It's a very small size of data. So once we call this Spark context.txt file, so what it will do is that it will load all the data, all the lines inside this word list into this initial RDD, which is a Java RDD containing all the string. And first of all, let me check that what is the number of partitions. I expect that because the data is so small, I mean, in terms of big data context, it should be only one partition. So if I run this, it will be evident that how many number of partitions we have. As we see, the initial RDD partition count is 1. Now let's, because as we know that repartition itself is actually, it will trigger a shuffle operation. So let's try to call this method, which will trigger a shuffle event. So here, let me change the partition from say 1 to 3. So I've taken this initial RDD and I called the repartition method so that from 1, I am increasing the number to 3, and I will store it in a variable. Say, yeah, repartitioned. I will mark it as repartitioned RDD. That's it, and mark it as final. Prefer to use final to make it immutable. Okay, now what I can see is that again I can just print it out that whether our number of partitions have been increased, because this will actually trigger it's a shuffle event, right? So trigger shuffle event. After that, let's print out the partitions which have been increased. So just printing out it after repartition, our partition count should be 3 because of this method, which is a shuffle event. And also I will use an assert equals to ensure that this is actually assert equals. I will just call 3 as repartitioned RDD got number of partitions. Just import it, alt, enter. Okay, assert equals. So let's run this. and see. So as seen that we have got after repartition, the partition count has increased to 3. So the basic thing that we want to discuss here is that repartition, when we call this repartition method, what it does is that it is actually triggers the shuffle operation. What it also means that, I mean, if you're talking about this, initially the whole data inside our word list or the file that we had, once we created a Java RDD out of that, in that case, it was only creating one partition because the data was small and it was spread only like in one RDD across one partition only. And once we call repartition and try to increase it from 1 to 3. So here I'm going to an example of 4, but just take an example that we have got 3 partitions after we call this repartition method. Once we call this repartition method to 3, it means that whatever the data that we have only in one initial partition of 1, it will try to spread the data across this word list across all the 3 partitions that we have. This is actually triggering a shuffle operation because it will take all the data and then spread across multiple partitions as we have called. So this is actually a shuffle event that we just triggered. Now let's take another example of reduceByKey.